Welcome to this video on designing and managing databases using cloud computing. This tutorial is prepared and presented by Agam Haidar Abdulwahed, a technical engineer. In this video, we will cover the basics of databases, including planning, the concepts of cloud computing, what low-code is, and provide examples of various cloud computing platforms. Let's begin by understanding what databases are. A database is a structured collection of logically related data. It consists of one or more tables, which are made up of records and fields. Database management systems allow users to efficiently create, read, update, and delete this data, focusing on organization and minimizing redundancy. Databases can be structured based on the mathematical relationships between data. Common models included the relational model, which is highly versatile, the structural model, based on organizational hierarchy, and the hierarchical model, where each element is linked in a tree-like structure. Next, let's explore the fundamental components that make up a database environment. The key components include the actual data, the physical hardware, software systems like operating systems and database managers, the people who use or manage the system, and the procedures or rules that govern its operation. Why are databases so important in the modern digital landscape? Databases are essential because they accelerate data access, facilitate complex updates, provide efficient responses to queries, and help organize vast amounts of information in a space-efficient manner. Key benefits include high speed, ease of data modification, efficient searching and sorting capabilities, support for multi-user access, interoperability with other applications, and improved security compared to traditional paper files. Effective database design requires careful planning and structural analysis, as illustrated in this schema diagram. When planning a database, remember to define clear objectives, name tables and fields appropriately, determine the correct data types, establish primary and secondary keys, and ensure that data remains unique to avoid redundancy. There are many industry-standard software tools for database design and management, such as Microsoft SQL Server, Microsoft Access, Oracle, and FileMaker, among others. Before implementing your database in software, it is best practice to first create a manual design plan on paper to map out your requirements. Finally, we introduce cloud computing, a modern approach that allows users to store and access databases and applications over the internet, providing greater flexibility and scalability for your data needs. Cloud computing essentially acts as a remote computer, accessible at any time and from anywhere. It consists of a large set of servers located in data centers, providing services to individuals and companies while hiding the complex technical details from the end user. Now let's look at some common examples of cloud computing applications. Email services are one of the simplest examples of cloud computing. Platforms like Gmail, Yahoo, and Hotmail operate in the cloud, allowing users to access messages without needing to maintain their own dedicated servers, storage, or complex software configurations. Cloud computing is categorized into several primary types. Public clouds provide resources over the internet shared by multiple clients, while private clouds offer dedicated infrastructure for a single organization, ensuring greater control and security over their specific data and operations. Hybrid clouds combine both public and private models, allowing organizations to share data and applications between them for increased flexibility, scalability, and optimized computing power. Cloud computing can be delivered in various forms, tailored to the specific needs of the client and the options provided by the service provider. These models, known as SaaS, PaaS, and IaaS, define how much of the infrastructure and software management is handled by the provider versus the user. This diagram provides a visual comparison of these service layers, illustrating the scope of control for both the consumer and the provider. Software as a service, or SaaS, allows you to use ready-made applications over the cloud. Platform as a service, or PaaS, lets developers build and manage apps without worrying about the underlying OS. Finally, infrastructure as a service, or IaaS, offers raw computing resources like virtual servers and storage. Cloud computing offers significant benefits, including high availability, fault tolerance, and scalability, allowing businesses to easily adapt to changing user demands without needing massive local hardware upgrades. Beyond scalability, cloud computing provides elasticity, guaranteed quality of service, and cost efficiency by allowing users to pay only for the resources they actually consume. Finally, here is a list of the top 10 leading cloud computing service providers for enterprises in 2023, reflecting the competitive landscape of the industry today. This list includes major providers like AWS, Microsoft Azure, IBM, Google Cloud, and Oracle Cloud, alongside other significant players such as Capgemini, Salesforce, SAP, DigitalOcean, and Rackspace. Cloud computing has become integral to many modern applications that we use in our daily life. These applications include social media platforms, cloud storage services like Google Drive, streaming apps such as Netflix, and intelligent personal assistants like Siri and Google Assistant. Beyond personal use, cloud computing powers productivity tools, business management software, digital marketing services, education platforms, and critical healthcare systems and smart home technologies. Let's now transition to discussing the concept of low-code programming. Low-code is a methodology that allows for the rapid development of applications through visual interfaces and drag-and-drop tools, minimizing the need for manual, complex coding and accelerating digital transformation. When choosing a low-code platform, it is crucial to determine who will be developing the applications, whether they are technical experts or non-technical staff, and to evaluate different use cases. You should also calculate your total budget and integration requirements, as some platforms charge based on the number of users or development scale, while others specialize in connecting to various data centers. Effective platforms support the entire development lifecycle, provide testing environments, offer continuous integration, and, importantly, meet high security compliance standards required by your business. Next, we will look at some practical examples of platforms used for designing cloud-based databases. One example is using dedicated low-code platforms for app development, which can simplify the creation of database-driven applications. Other workflows, such as setting up a Google account, can serve as the foundational step for accessing cloud-based services and database management tools. Thank you for watching this video. We hope this information helps you in your journey of designing databases with cloud computing.